Arithmetic in Base 10. Students will learn to use efficient algorithms to fluently calculate sums, difference, and products of multi-digit whole numbers. Are long division, quotient, and variable. We often use decimals when dealing with money. In these situations, sometimes we round and make estimates, and other times we calculate the numbers more precisely. There are many different ways we can add, subtract, multiply, and divide decimals. This unit will explore these options as you work through the unit. The key is to always line up your decimals when adding and subtracting. In multiplication and division, that is not important, but place value is. This unit starts by solving real-world problems using decimals. For adding and subtracting, always line up the decimal before computing. Base 10 blocks are heavily used in this unit. Base 10 blocks are used to demonstrate place value. The goal is for you to learn that our number system is based on powers of 10. For every 10 of any place value you have, that turns into 1 of the next higher value. You will first calculate sums of two decimals by representing each number as a base 10 diagram, combining representations of like base 10 units and replacing representations of 10 like units by representation of the unit of its next highest value. For example, 10 ones blocks are equivalent to 1 10 frame. Diagrams to represent multiplication. Here is a diagram of a rectangle whose side lengths are 3 4/10 units and 1 2/10 units. Its area in square units is the product. To calculate this product and find the area of the 3 4/10 and 1 2/10, we can decompose each side length into its base 10 units. 3 4/10, the 4/10 equals 3 plus 0, and 1 2/10, the 2/10 equals 1 plus 0, decomposing the rectangle into 4 smaller sub-rectangles. We can rewrite the product and expand it twice. Here you see the 3 4/10 times 1 2/10, broken down or decomposed into 3 plus 4/10 times 1 plus 2/10. Then again, broken down to 3 plus 4/10 times 1 plus 3 plus 4/10 times 2/10. In the last expression, each of the 4 terms is called a partial product. Each partial product gives the area of a subrectangle in the diagram. The sum of the 4 partial products gives the area of the entire rectangle. We can show the horizontal calculations above as 2 vertical calculations. The sum of the values is 4 8/100 square units. In the final section of this unit, students will learn long division. They begin with quotients of whole numbers, first representing these quotients with base 10 diagrams, then proceeding to efficient algorithms, initially supporting their use with base 10 diagrams. Students tack quotients of whole numbers that result in decimals, quotients of decimals and whole numbers, and finally quotients of decimals. This part of the unit will take repetition and practice to master. Do not give up. The method you see here is the partial quotient method. Students use what they know to slowly break up the dividend. First, the student starts with the dividend, 657, and the divisor, 3. He then subtracts 3 groups of different amounts from the 657, starting with 3 groups of 200. Then 3 groups of 10, and 3 groups of 9. The student calculated 200 plus 10 plus 9 and then wrote 219.